Okay, so I will be demonstrating problem 1 on the Physics 1 exam. In this problem, it asks you to find the magnitude of the net force on charge negative q prime, which is this top charge right here. And in order to go about that, first you need to establish a coordinate system so that you can find your relative position vectors. So I set my origin at 3q down here, labeled this in the x direction and this in the y direction. And in order to find even the electric field acting on negative q1, um, you need to find the relative position vectors first for charges 3q and negative q. So what I did here is you have E net equals E3q plus E negative q, and that should give you the net electric field acting on negative q prime. So I got my first position vector R1, which is for particle point charge 3q. Um, and by doing some basic trig, you can find that the position vector is L root 3 sine theta, L root 3 cosine theta. And same thing for R2, which is from negative q to, or negative q to negative q prime, which is L root 3 sine theta, L root 3 cosine theta, minus L root 3 sine theta, L sine theta, plus L sine theta, comma L root 3 cosine theta minus L cosine theta, just by doing some basic trig within the origin, or about the uh, system. And so that would give you negative L sine theta, L cosine theta. So now that we have our relative position vectors, next thing you have to do is apply the electric field of a point charge formula, which is for E3q, 1 over 4 pi epsilon naught times 3q over R1 cubed times R vector R1. And then same thing for negative q, same process. And you should get that these root 3's will cancel out, and these 3's will cancel out, making it really easy. And same thing for E negative q, you will get that it will all come out to be even numbers. So it actually makes it really easy later on, because when you find the net force on negative q1, all you have to do is multiply by negative q1 prime over, and as you can see in the y direction, these two terms cancel out. So the net force acting on negative q1 or q prime will be all in the negative x direction, because you have this negative and these are both positives. So when you add these two together, you have you basically have q sine theta over L squared, q sine theta over L squared, so that's 2 q sine theta over L squared, times negative q prime over 4 pi epsilon naught. So that gets you to your magnitude of your force, net force on negative q prime, to be q1 or q times q prime sine theta over 2 pi epsilon naught L squared newtons. And where you might ask, I got this 2 pi epsilon naught, I just cancel out the 2 from the top and the 4 on the bottom. And so basically from this arrow, which it asks you later in the problem, you can determine the arrow for the net force acting on charge negative q prime. So if you flip to the other side, yeah, the direction of the force acting on charge negative q prime is in the negative x direction. And for this, we kind of already solved for this. The net field, what is the magnitude of the electric field acting at location negative q prime due to the other two charges? We already solved for this earlier. So that's just taking it from this right here, this part down here, without this negative q prime. And then down here, this can be somewhat tricky, but the direction of the electric field is in the positive x direction and not the negative x direction because of this formula. Force equals q times electric field, and since you're using a negative q, you have to negate your force, which means your force is going to be in the negative x direction, whereas your field is in the positive x direction. So that's problem 1 in basically explained completely.